You wake up and three accounts are gone. Not one, not two, but three. All created around the same time, all running through the same setup, all dead within a few hours of each other. If you run more than a handful of accounts for any length of time, you've seen this exact thing happen to you, and it probably happened more than once. It doesn't feel random when it's sitting in front of you, and it isn't. Platforms very rarely ban accounts one at a time, as people individually slip up. They sit back, collect evidence, cluster it together, and swing the axe on the whole group at the same moment. That's what people mean when they talk about a ban wave. I run real proxy and cloud phone infrastructure for a living, and I test anti-detect browsers against that infrastructure constantly. So none of this is theoretical for me. It's what I watch happen on my own accounts every week. The batches you see aren't bad luck, and they aren't a coincidence of timing either. They're the direct, predictable output of how modern detection systems are actually built. Once you understand the mechanism underneath it, the pattern stops looking mysterious and starts looking like exactly what it is, a system doing its job. The first thing to understand is that most platforms do not ban in real time, even though it can feel that way from the outside. A login that looks slightly off doesn't get an instant red card the moment it happens. Instead, it gets flagged, scored, and quietly queued for review somewhere in the background. The system keeps collecting signal the entire time. Device fingerprint, IP reputation, behavior patterns, how the account interacts with other accounts on the platform, and whether it shares infrastructure with accounts that are already known to be bad. That delay is deliberate, not a bug or an oversight in the system. If a platform banned instantly on the very first suspicious signal, it would tip its hand immediately and let operators iterate against the detector in real time, tweak one variable, try again the next day, and slowly learn exactly what triggers the ban. By waiting and batching instead, the platform hides which specific signal actually crossed the line. You lose 10 accounts at once, and you genuinely don't know if it was the proxy, the fingerprint, the behavior, or some combination of all three working together. That ambiguity isn't an accident, it's the entire point of running things this way. The technical reason accounts end up dying together is clustering. Detection systems don't sit there and evaluate a single account in isolation the way a human moderator might. They build a graph. The nodes in that graph are accounts, sessions, and devices. The edges connecting those nodes are shared attributes between them. The same canvas hash, the same WebGL renderer string, the same font list, a time zone that doesn't match the IP address, the same TLS handshake fingerprint, the same behavioral timing curve, repeated across supposedly separate people. When enough accounts share enough of these edges, the graph algorithm groups them into a cluster and starts treating that entire cluster as a single actor wearing many different masks. This is not exotic technology either. It's the same graph-based approach fraud teams and social platforms have used for over a decade to catch coordinated behavior, just tuned and retrained specifically for account farming and multi-accounting instead of payment fraud. The underlying math doesn't care whether you're an operator running 10 accounts or a fraud ring running 10,000. It just looks for dense clusters of shared attributes and treats density itself as the warning sign. Once one account inside a cluster trips a hard rule, a chargeback, a scraped price check, a report from another user, an obviously automated action, the platform doesn't just quietly review that one account by itself. It pulls the whole cluster and reviews everything connected to it in one pass. If your 10 accounts sit inside one cluster because they were all built from the same profile template, the same browser version, the same GPU signature, or the same narrow IP range, then one mistake anywhere in that cluster can take every other account down along with it, even the ones that never did anything wrong on their own. That's the batch death you've actually experienced firsthand. It isn't that the platform independently discovered 9 other bad accounts at the exact same moment you happened to get unlucky. It's that the system already knew those accounts were connected long before anything happened, and it was simply waiting for one good enough reason to act on the whole group at once. The wait is exactly what makes the ban feel sudden and disconnected from anything you actually did that day. Anti-detect browsers exist specifically to reduce how many of those shared edges sit between your different profiles. Tools like multilogin, GoLogin, Camelio, AdsPower, and Dolphin Anti let you assign each browser profile its own canvas noise, its own WebGL and audio fingerprint values, its own font and plugin list, its own user agent string and hardware concurrency reporting. And they keep cookies and local storage fully isolated from one profile to the next. Done properly, that kind of setup makes each profile look like a genuinely different piece of hardware being run by a genuinely different person, instead of the same Chrome install cloned 10 times over and pointed at 10 different accounts. That's a real function, and it's a genuinely useful one for anyone managing more than one account. It is not, however, the same thing as making an account unbannable, and it does not make an account undetectable either, no matter what the marketing copy on some of these tools might imply. Fingerprint spoofing addresses exactly one category of signal out of several the platform is actually watching. It does nothing by itself about IP reputation, nothing about account behavior, nothing about the payment and device graphs tied to phone numbers or email addresses, and nothing about the platform's own historical data on how real users of that specific service actually tend to behave over time. I've tested several of these tools directly against my own farm, running the same workflow across dozens of profiles, and the honest takeaway is that fingerprint diversity buys you separation, not immunity. A cluster can still form on network signal alone, or on behavior alone, even when every single fingerprint value on the profile is different from the next. I run proxy infrastructure for a living, so let me say plainly where a lot of operators get this backwards, because I see it constantly. A clean, unique fingerprint sitting behind a dirty or shared IP still clusters, full stop. Data center IPs get flagged by ASN alone, almost trivially, before the platform even looks at anything the browser is reporting. Residential proxy pools that get reused across many different operators, or that keep rotating through the same narrow subnet over and over, create exactly the kind of shared edge that groups accounts together, no matter how different the browser fingerprints happen to look on paper. Mobile and residential IPs with clean, unshared history genuinely make separation more plausible, and that's part of why I run the infrastructure the way I do. But even then, if 50 of your accounts route through the same handful of gateway IPs on a fixed, predictable schedule, the timing pattern itself becomes a shared signal all on its own. The fingerprint layer and the network layer both have to be genuinely distinct at the same time, not just nominally different on a setting screen somewhere, or the cluster forms anyway regardless of what any individual fingerprint value happens to report. The third leg holding all of this up is behavioral, and it's the one anti-detect browsers can't touch at all, because it isn't a browser property in the first place. It's a pattern in how a person actually acts. Typing cadence, mouse movement, click timing, the order you visit pages in, how long you dwell on a page before acting, whether 10 supposedly different, supposedly unrelated accounts all log in inside the same 2-minute window every single day like clockwork. Automation and scripted flows tend to be far more uniform than real human variance ever is, and that uniformity is itself a fingerprint, maybe the hardest one of all to fake convincingly. Detection systems that build behavioral graphs will cluster accounts on timing correlation alone, even when the device layer and the network layer are both completely clean and fully diversified. And this is also where I'm going to stop and not go further, because walking through the specific ways to make automated behavior pass convincingly as human is a bypass guide, not an explanation of how the underlying system works, and a bypass guide isn't what this channel is for. So what actually moves your odds? Based on what I've personally seen running real infrastructure against these tools for years now, day in and day out. Separation has to be real at every single layer at the same time. Fingerprint, network, and behavior together, not just one of the three in isolation, while the other two stay identical across accounts. A unique canvas hash paired with a shared IP and identical login timing is still just one cluster wearing a few different masks, no matter how convincing any single layer looks sitting on its own. Fewer, better isolated accounts tend to hold up meaningfully longer than large batches built off one shared template. Every shortcut you take to scale profile creation faster, cloning a base profile, reusing the same proxy pool across accounts, running everything on one fixed schedule to save time, adds a shared edge straight back into the graph you were trying to avoid building in the first place. Every shared edge is one more thread quietly connecting accounts you want it to look completely independent of each other. And none of this is permanent, which is the part people forget fastest. Detection models get retrained on new data. New signals get added on the platform side without any announcement, and a configuration that worked cleanly 6 months ago can start failing without anything on your end actually changing at all. Treat any result you're seeing right now as a snapshot taken at one point in time, not as a guarantee that carries forward into next month or next year. This happened firsthand with setups on my own farm. A proxy and profile combination that ran clean for weeks suddenly starts throwing flags after a platform update, and there's no change log telling you what changed on their end. You just have to notice the pattern and adjust. Ban waves happen because detection is built around graphs, not around individual accounts viewed one by one, and platforms deliberately delay taking action specifically to hide which signal is the one that actually gave you away. That's the real mechanism underneath the whole thing, and once you actually see it clearly, the batches stop feeling random and start feeling like exactly what they are. Antidetect browsers are a real, legitimate tool for reducing fingerprint-level clustering between your profiles, and in my own hands on testing the difference between a careless setup and a careful one is significant and genuinely measurable across dozens of accounts. But no tool in this category, and no combination of proxy setup and browser setup together makes an account unbannable or removes the underlying risk you're taking on. Anyone telling you otherwise in a review or a sales page or a comment section is selling something, not testing something. I test these browsers on real multi-account setups, so the written reviews and the picks I actually trust are all at antidetectreview.org. Full written reviews and tested picks at antidetectreview.org, so go check them out for yourself and subscribe here for the next breakdown.